is for Year 10 Methods Pathways. We're going to look at exercise 10.3, question number 10. And this is an open-ended question, meaning you can have a variety of answers. There's no set one answer. Okay, so that's what open-ended means. So if you get an answer that's different from the back of the book, that's okay, as long as what it requires in the question is satisfied. So we've got a 20-sided die. Okay, that's probably a very special type of die because usually dies are 6-sided, but in this case it's 20-sided and the sides are numbers from 1 to 20 and the die is rolled once. Okay, so for this situation, list 4 pairs of events that are mutually exclusive. So mutually exclusive means there is no overlap between the events. Okay, so we'll choose a very simple example, or choose a very simple case. If I roll a 1 as event A and roll 2 in event B, they're mutually exclusive because you can't roll 1 and 2 don't overlap at all. Another one is if A is odd, B is even. So if you roll if A is rolling an odd number and B is rolling an even number, then obviously they don't mix at all. There's no common value. Whoops, third one. If A is, let's just say 1 to 5, and B is 6 to 10, that's another example of 2 events that are mutually exclusive. Again, there's no overlap at all. Now, I'll just do 3 examples. I'll let you figure out another one. So the key for these questions is don't try to overcomplicate, make it as simple as possible, because you're not going to get extra marks for making it really fancy. Part B lists 4 events that may overlap. Okay, so A is multiples of 2 and B is multiples of 3. Now, why does that overlap? Because numbers such as 6 are both multiples of 2 and 3, or 12 or 18, or 24. So there's definitely the events of A and B are definitely not mutually exclusive. Another one, A is between 1 and 15, so rolling a number between 1 and 15, and B is rolling a number between 10 and 15. So as you can see, A and B overlap. Another one, multiples of 5 and B multiples of 10. So as we can see, the 10, 20, 10 and 20 numbers, well, numbers 10 and 20 would be what A and B overlap in. Okay, and I'll leave another one for you to figure out. Now, part C is an interesting one. Describe how events that A and B, so that the probability of A is half, probability of B is 3/4, and the probability of A or B is 17 out of 20. Okay, so we are trying, so essentially they've got a not a mutually exclusive scenario here. They want you to create a scenario where A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay, so the probability of A and B, A or B is 17 out of 20. The probability of A is a half. So for convenience sake, because we're doing fractions, I want to change this to, I want to change it to out of 20. So a half of 20 is 10. 10 on 20 is the same as a half. And probability of B is 3/4. Oops, that's B. Probability of B is 3/4, so that's 15 out of 20. If you 3/4 is the same as 15 out of 20 minus the probability of A and B. Now let's add these together. So that becomes 25 on 20 minus the probability of A and B. Now I can figure this out because I know the result we want is 17 out of 20. 25 out of 20 minus something gives you 17 out of 20. So we know that the probability of A and B is 8 out of 20. So we need to find a scenario that the probability of A is a half and the probability of B is 3/4, and the probability A and B is 8 out of 20. Okay, like I said, I want to find something that's not complicated, so let's do it in a systematic way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, if I let event A, so I want event A to be a half, okay? So let's choose the first half of the 20 numbers. So we'll call that event A, okay? So that's event A. Event B is 3/4, okay? And we've got 8 out of the 20 that overlap, okay? So I'm going to deal with the overlap first because I want to satisfy the condition. So I'm going to say this overlaps, this overlaps, this overlaps, 1, 2, 3, 4, 5, 6, 7, 8. Now, so that's part of A and B. So it's part of B as well. So B's got 1, 2, 3, 4, 5, 6, 7, 8. Now, I need, for B, I need 3/4. I need 15. So I've got 8 already. I need 7 more. 1, 2, 3, 4, 5, 6, 7. So let's go back to the pen. This is event A. This is event B. So let's check whether we satisfy the condition. Does the total of A and B add up to 17 out of 20? Let's count all the, all the colored numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Perfect. So we satisfied the total count. We've satisfied the total count at 17 out of 20. Good. The probability of A is 10 out of 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We've satisfied that condition. And probability of B, which is blue, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. So event A is getting a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the probability of the event B would be rolling a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so that's a very simple case I've done. I've tried to, choose the easiest way, and I believe this one's the easiest way to achieve what we want in the conditions. Hopefully this helped.